13.3, finding functions. Once you've copied the lesson objective down, hit play and we'll talk about finding functions. So when we say finding functions, what exactly do we mean? Well, when we integrate a function, we get the original function back, but we get a constant as well. And what this constant does is it allows the function to shift up or down the y-axis. So it can take any value whatsoever along the y-axis. Let's have a look at an example. Say we've got 2x and we want to integrate that. So we add 1 to the power, takes us to 2, divide by 2, and the integral is x squared, but we've got that constant. So that constant could take any value. It could be 1, it could be minus 5, it could be anything. These are good examples though. We draw them on a graph. So it could be either of these, but it could be any value whatsoever along the y-axis. So it shifts up and down the y-axis. It's your basic transformation. Now, to be able to find the exact value, what do? These are identical curves. The gradients of these points are exactly the same. So what do we do then to find the exact value of C? Well, we need something. We need something extra. And what we need is a coordinate anywhere along the curve. If we have one coordinate along the curve, then we can use that. We can put that back into the function, and then we can find C, the constant term. Right then, let's have a look at this example. We've got our curve x with the equation y equals f of x passing through the point 215. So we've been given a point on the curve. Given that the differential is equal to 5x squared plus 3x, find the equation of x. Okay, so we've got our differential, f dash of x, which is equal to 5x squared plus 3x. So if we integrate that to give us f of x, we get, add 1 to the power and divide by that, 5 over 3 x cubed plus 3 over 2 x squared plus our constant term, which we need to find. We can find, because we've been given a point on the curve, 215. Y equals 15, x equals 2. So subbing that for x and y at 215, we get 15 is equal to 5 over 3 x cubed, so 2 cubed, plus 3 over 2 times 2 squared plus c. So if we simplify, c is the only unknown in this expression. So we've got 15 is equal to 8 times 5, 40 over 3, plus one of the 2's cancel, so 2 times 3 gives us 6 plus c. So if we take 40 over 3 and 6 over to the left hand side, let's rewrite it as c is equal to 15 minus 6 minus 40 over 3. So that's going to be 15 minus 6 is 9 minus 40 over 3. 9 times 3, so that's going to be 27 over 3 minus 40 over 3, which is 13 over 3. Oh, sorry, minus 13 over 3, which is also the same thing as 4 and a third. Sorry, minus 4 and a third. Okay. And so, our original equation is given by, just change to a different color. Blue. So original equation is given by this one. This implies that f of x is equal to 5 over 3 x cubed plus 3 over 2 x squared minus 4 and a third. Now I'm happy if you use 4 and a third. I'm also happy if you use minus 13 over 3. I actually prefer minus 13 over 3, especially seeing as we've got 5 over 3 and 3 over 2. Okay, but either one is correct. Right, hit pause, copy the example down. Once you've done that, hit play and we'll look at another example. Right, let's have a look at this. So we've got a curve x, we use x a lot, given by the equation y equals f of x, and it passes through a point 4,5. Same sorts of thing. Our equation, our differential is given by x squared minus 2 divided by the square root of x. Find the equation of x. Okay, so same sort of thing, just change back to red. So f dash of x is equal to x squared minus 2 over the square root of x. Looks challenging, but if we separate the two terms on top, so we got x squared divided by the square root of x, or x to the power of a half, minus 2 over x to the power of a half. Simplifying, we get, subtract the indices, so 2 minus a half leaves us with x to the power of 3 over 2 minus 2x to the power of minus a half. So now we can find f of x. We integrate, f of x is equal to, add 1 to the power, gives us 5 over 2, so it would be x to the power of 5 over 2 even, divided by 5 over 2, minus 2, x to the power of, add 1 to the power, becomes a half, divide by a half. And if we simplify, we can multiply by the reciprocal. So don't forget, we can flip it, 2 over 5, x to the power of 5 over 2, minus, flip it, so it'll be 2 times 2, so minus 4, x to the power of a half. And we are missing our constant term, plus c. So now we've got to find out what c is, given the point 4, 5. So as before, I'll just change color. So as before, we've got, we're going to sub for x and y at the point 4, 5. When we do that, f of x is now 5, is equal to 2 over 5, 4 to the power of 5 over 2, minus 4 times 4 to the power of a half, plus c. So simplify to find c. We've got 5 is equal to 2 over 5. Now that's the square root of 4, which is 2. In fact, let's just write it in full. So square root of 4 to the power of 5 minus 4 times the square root of 4 plus c. And when we work that out, it's going to be 2 to the power of 5, which is 32, minus 4 times 2. 5. So c is going to be equal to 5 plus 8 minus 64 over 5. And simplifying that, we've got 13 minus 64 over 5, which is equal to 65 minus 64 over 5, which is 1/5. So the original equation is given by this term here. So f f of x is equal to 2 over 5 x to the power of 5 over 2 minus 4x to the power of a half plus 1 out of 5. Okay, so I want you to hit pause, copy the example down. Once you've done that, hit play, and I've got a couple of questions for you to attempt. Right, some questions then. Well, integration is quite new, so it's probably worth doing all of question 1 and working your way through slowly. Okay, I think we've got 8 questions, and if you're feeling bold, a challenge. Okay, good luck.